Welcome to the DIY Honda Garage channel. In the Honda CR-V 2023 Plus, the DTC P16F4 corresponds to a low voltage issue within the starter cut relay 2 control circuit. This error occurs when the return signal from starter cut relay 2 is identified as low while the starter is off. The Powertrain Control Module, PCM, monitors this signal to detect any abnormalities that may arise. Proper functioning of the starter cut relays is crucial for the vehicle to start smoothly, as they interrupt power in the circuit when the engine is off, preventing unintentional engine starts. This problem, if not addressed, could lead to difficulties in starting the vehicle or might keep the engine from operating as intended. The detailed diagnostic procedure aims to identify and rectify the underlying issue, ensuring all components are functioning correctly and efficiently. A thorough inspection of the relevant circuits and components is essential for maintaining the overall health of the vehicle's electrical system. The starter cut relay 2 is part of the vehicle's electrical system, responsible for controlling power to the engine's starting mechanism. Specifically, this relay helps to ensure that the engine does not start unintentionally when the vehicle is off. The Powertrain Control Module, or PCM, plays a critical role by monitoring the status of this relay. It analyzes input signals from various components to maintain proper vehicle operation. The PCM is usually located within the engine compartment or cabin of the vehicle, depending on its design. Understanding the physical layout of components, including the starter cut relay and PCM, is vital during troubleshooting. By knowing where these components are located, technicians can perform effective inspections and pinpoint potential issues accurately. Several factors may lead to the DTC P16F4 being triggered. First, low voltage conditions in the starter cut relay 2 control circuit may cause the PCM to receive incorrect signals. This can often stem from issues such as corroded wiring, damaged connectors, or poor circuit integrity. Secondly, faulty circuit connections can disrupt the normal operation of the starter cut relay. These connections may experience wear and tear or become loose over time, affecting the relay's performance. Lastly, a malfunctioning PCM itself could also lead to this error code being generated. If the PCM cannot correctly interpret signals due to internal failure or software issues, it might incorrectly register low voltage when in fact the circuit is functioning normally. When encountering DTC P16F4, the driver may experience several issues. The most noticeable symptom is an engine that fails to start, leading to frustration and inconvenience. The user might turn the key or push the start button, only to find that the engine does not respond. Additionally, the starter relay might exhibit erratic behavior, leading to intermittent starting issues or, in some cases, preventing the engine from starting altogether. Such connectivity issues may also result in unexpected behaviors while driving, including stalling or unresponsiveness. Recognizing these symptoms early on can lead to prompt troubleshooting and repairs, ensuring the vehicle remains in safe operational condition. The first step in troubleshooting the DTC P16F4 is to ensure that the engine is in the on mode. This allows the Powertrain Control Module to properly assess the operational state of the starter cut relay 2 and determine if the low voltage conditions are indeed present. Checking the service manual is also essential in understanding the intricacies of the diagnostic process. This resource can provide valuable insights and step-by-step guidance for the technician performing the troubleshooting. Confirming the presence of the DTC ensures that the root cause of the issue is being addressed and sets the stage for more detailed inspections that follow. Proper completion of this initial step is crucial to avoid misdiagnosing the problem in subsequent steps. The next step involves inspecting the external circuit associated with the starter cut relay 2. This entails checking specific components such as the IG1 ACG and IG1 starter cut circuits to ensure they are functioning appropriately. Technicians should look for any signs of wear, corrosion, or damage that could affect the overall circuit performance. It is also essential to verify voltage levels in the wiring during this stage, especially when the ignition is switched to the on position. Confirming that the voltage aligns with normal operational standards is necessary to determine whether the circuit is intact or if faults need rectification. Efficiently diagnosing problems in the external circuit is critical to ensure the vehicle's starter system operates as intended. Continuing with troubleshooting, the next step is to perform an open wire inspection. This step involves checking for continuity in the ST cut roll kernel CL. It is essential to ensure that there is less than 1 ohm of resistance present. Any higher resistance might point towards a break or fault within the wire. Following the open wire inspection, the technician will perform a check for any shorted wires. This involves inspecting the ST cut roll kernel CL for shorts to ground, where ideally the resistance should be more than 1 megaohm. These measurements are crucial in determining whether the wiring is capable of delivering the correct signals to the circuit reliably. Diagnosing these potential wiring issues accurately can help prevent further complications with the vehicle's starting system. After completing the troubleshooting steps and any necessary repairs, the technician must conduct a final verification to confirm that the issue has been resolved. This includes reviewing all repair work to ensure that everything is functioning as expected. Clearing the DTCs using the diagnostic tool will reset the PCM, allowing it to re-evaluate the circuits. Following this, testing the engine functionality is vital. The engine should start without any irregularities during this phase. If the engine starts smoothly and there are no outstanding DTCs, it indicates that the repairs were successful. This final verification step is crucial in certifying that the original issue regarding the starter cut relay 2 low voltage is fully addressed. Preventive maintenance is essential for avoiding future issues related to DTC P16F4. Regular circuit inspections can help catch any problems before they escalate into more serious issues. Technicians should routinely check the integrity of electrical wiring, ensuring that connections remain clean and free of corrosion. Over time, wear and tear on these components is inevitable, so addressing any signs of erosion early can significantly reduce the likelihood of failures. Furthermore, keeping the Powertrain Control Module updated with the latest software is an important step for maintaining optimal vehicle performance. Proper preventive maintenance can save time, costs, and prevent inconvenience during vehicle operation. In summary, addressing DTC P16F4 in the Honda CR-V requires a structured approach to troubleshoot and resolve starter cut relay 2 control circuit issues. Understanding the roles of the starter cut relay and the PCM is pivotal for effective diagnosis and repair. Regular inspections and maintenance of related components are essential steps to ensure the vehicle operates smoothly. The check for low voltage conditions in the circuit, alongside effective inspections for potential wiring faults, allows technicians to rectify issues promptly. Maintaining the vehicle through preventive measures will enhance its reliability and longevity, minimizing the risk of unexpected starting problems in the future. Ultimately, a proactive approach to vehicle maintenance and troubleshooting will lead to better performance and customer satisfaction. Please like and subscribe to the channel. See you next time.